We'd like to go ahead and invite Aris MD to the stage.
Hi there. I'm Scott Edgar. I'm the CTO and co-founder of Aris MD, and this is my partner, Chandra Devam, CEO of Aris MD. A couple of years ago, my co-founder Chandra had an operation and almost died on the operating table. She was undergoing a simple day surgery that should have been a very simple in and out, but the surgeon nicked an artery because he didn't know it was there, causing her to nearly bleed out and require a blood transfusion to save her life. This led to a bunch of questions. What happened? Was it the surgeon's fault? Who was to blame here? And the answer was surprising, because the truth is that we're as different on the inside as we are on the outside. If you look around the room, everybody's got eyes, they've got a mouth, they've got a nose. We all have the same features, but we all look very different. It's no different on the inside. We all have a heart, we all have lungs, but the placement is different between each and every one of us. Surgeons know, generally speaking, where these things are inside your body, but they don't know exactly where they are. So in effect, they're cutting in blind. Now, in 2016, 425,000 people died of avoidable medical error. Did you know that avoidable medical error is the third leading cause of death in the United States? We're losing a city the size of Atlanta every single year. We're losing a city's worth of people every year to avoidable medical errors. So what can we do about it? Right now, when you go into the doctor, if you have something wrong, they do medical imaging. They take an MRI, they take a CT, an ultrasound, an X-ray. These generate a vast amount of data, too much for a human to conceivably go through all of this data by hand. So they break it down into slices. You get slices between 1 and 4 millimeters apart. Now, if you happen to have a tumor or a bleed that's in between these slices, it gets missed. It can delay your treatment, or maybe you never get treated. So what do? We take all of these images and we bring them into 3D and create 3D visualizations. Now, when a doctor or radiologist looks at this 3D image of a brain or a heart or a lung, they have an organic view of what these organs actually look like and not slices like looking at photographs. This allows them to make a more effective and accurate diagnosis much more quickly. And they have all of the data. We don't discard all of this extra data. Now, using these visualizations, they can take this into 3D to practice and plan the surgery. They can create a map so that they know what they're doing for your procedure. They can then take this map and overlay it on you in augmented reality during the procedure. They can follow the map, like Google Maps for a surgery. What's the problem in space? Well, if you have all of these specialist doctors for all these different types of surgeries, they spend 15 years training to be able to perform that surgery. Astronauts spend a number of years training to become an astronaut. We can't conceivably train somebody to be both a surgeon in multiple disciplines and an astronaut. There just isn't a way to do that. So we need another solution. The solution for us is artificial intelligence and autonomous medicine. Combining the ability to use artificial intelligence to make a diagnosis, we can work with robotic systems to create things such as a medical pod, for example, which would allow artificial intelligence and perhaps distant guidance to operate on somebody in space on long-range missions. Right now, this isn't a possibility, but we can make it happen. The technology itself, we have a proprietary stack which is completely cross-platform. We have filed patents internationally, and we have had years to work on and refine these technologies. By compiling these things into 3D, we can, and in real time, I must add, we can compile these images by the time your scan is finished, so that when you get your scan done, the doctor is ready to use it on you immediately. This could save your life. There are many other people who are trying to do similar things, but they all have something in common. They can't do this stuff in real time. What they do is they'll have a radiologist mark up each image in a series. And it could be dozens of images, it could be hundreds of images, in some cases thousands of images. And as they mark up those images, they pass them on to a 3D modeling specialist, who then creates what, in effect, is an artist rendering of your body. They use this to practice. They use it to plan the surgery. But if you go into the hospital and you have something bleeding in your brain, you don't have time for somebody to go through and mark up all these slides, or time for somebody to go and make this model and send it back to your doctor. It needs to happen right now. So what we do is saving time and it's saving money. But most importantly, we're saving lives. Now, our business model is fairly simple. We have an initial site fee for each of the hospitals involved. And in addition to that, we charge a seat-based licensing for each surgeon. Now, this is an enormous market. In 2017, healthcare spending in the United States was $3.5 trillion. Surgical applications are a significant component of that. There are 6,210 hospitals in the United States, of which most belong to large hospital consortiums like Kaiser Permanente. Those consortiums are an excellent place for us to start these conversations and talk with these doctors and try and push our systems into thousands of hospitals at once, rather than knocking on the door of each individual hospital. And this is just a piece of our market. One of the things that I should have mentioned earlier is that with people like NASA, for example, we can do materials inspections. So when NASA orders components, they need to scan them to verify the authenticity. We can take those scans and bring them into 3D, saving thousands of hours. We can also scan things like rocket engines or jet engines, looking for cracks. And finding those will allow us to not just save time and money, but potentially avert disaster and save lives. Now, my co-founder, Chandra, has been building businesses since she was 11 years old. I've never seen a business of hers fail. She's an amazing lady in that regard. And her passion for technology and writing patents, her history with Microsoft and Xbox, she's an amazing boon to the company. Myself, I started programming at 4 years old. We've had several successful companies together, the last of which sold to Apple a few years ago. Yeah, we often like to say that Chandra writes these beautiful sci-fi in patents, and I make them real. We also have a great team of advisors. Dr. Carrie Allen Jones, who is our chief medical officer out of Peninsula Orthopedic. She's a triple board certified surgeon and a generally amazing lady. Angelo Del Priore, who is a partner with HP Ventures. Rahul Dutta, who is a managing director with Evercore. And Terry Kilburn, who is a founder of a company called Avis & Young. So at Aris MD, we're saving time and we're saving money, but most important of all, we're saving lives. Chandra, was there anything you wanted to add?
I think I'd just like to thank NASA and NASA iTech and Kira Blackwell and specifically for this program, and I'm sure all of us feel this way. I know that wherever our company goes, you're a big part of it. So I want to say publicly, wherever we end up, you're the reason we got there. Thank you.
Thank you.
Judges, any questions?
I didn't hear what you were asking for. Or are you looking for money, or where are you? And
So we're taking a small amount of strategic money at this point. As Scott mentioned, a company sold to Apple, so we've been living off the apple tree, which is good apple sizes. So we're pretty good on that sector. We're just here. It's an honor to be here. So one of our asks here is that we're here because it's an honor. And some collaborations. We're looking for collaborations and partnerships.
do you you said that, I mean, your medical emergency there, have you got an example of, can you throw us a 3D image of how it would have helped? Or a 3D image of the materials? I would really love to see that.
I can potentially do that offline.
Guys, one of the things, it's Rich over here.
Yeah,
One
yeah.
of the things that has intrigued me since I first met you guys was that what you're doing is not necessarily unique in terms of the fact that there are other people out there that have tried to put augmented reality into this medical surgery system. How do you, without telling us what you can't tell us, how do you separate yourselves from that crowd of people that have been trying to do that?
That's a really good question. So Scott lightly touched on his ability to build things. He built a really powerful proprietary rendering system. So we're not modeling our images, we're using true DICOM and all of the information's there. So we're not altering it, we're not taking anything away, we're keeping all of it, and we have the ability to show all of that information very quickly without a lot of power. So that sets us apart. Am I speaking into this okay?
Yeah, and I think actually
I'll let Scott touch on that a bit.
something that I meant to mention in the presentation, I realized that I missed, is that we're doing this all on a single computer. So we don't require any cloud resources. There's no cloud processing. There's no cloud storage, which means that we can work offline in any situation. So be it on a spaceship, be it in your backyard, or be it during a network outage, our system still operates seamlessly.
So you mentioned DICOM, which
Yes.
is a medical standard, if I understand correctly.
Yep.
I have a background in some building and construction technology, and over there's BIM and there's CAD. And that's obviously, as you've said, in your market share, those kinds of things, larger scale physical things, are a big component of what you could address.
Yep.
Are you currently working with any other 3D standards, or have you been focused on medical for now?
Do you want me to take that?
I can
Yeah.
answer it. So we're focused on DICOM right now, but there isn't any reason that we couldn't do an expansion into some of those other areas. Primarily for us, though, the imaging has been the focus thus far. So even in those types of applications, a lot of that is done with industrial CT, which also comes into a DICOM format. So the file formats there are identical.
As is X-ray, which is sometimes used as well, or ultrasound in pipelines. They use ultrasound, which is also DICOM. It's an
It is an IEEE
IEEE
standard.
standard
yeah.
across, so that's global.
So maybe one day PG&E will have a tablet that will tell them if they're about to dig into an electrical line they actually own.
You bet.
It could
Wow.
happen. We can keep power to you.
On your left. Do you guys focus on a particular type of surgery? You had the imagery of a brain surgery. Is
Yeah.
that the particular focus, or is it any kind of surgery?
Any kind of surgery, and actually extending out of surgery, so we can do optical, dental surgeries, orthodontic. We're not limited there, nor our patents aren't specific to medical.
And then your revenue slide. Did it say you're going to do $2 billion in revenue in your first year?
It probably said more, but yeah, we're already in talks for. I have to be careful what I say here. We have offers for licensing in large ranges.
So your projection is you're going to do $2 billion in revenue your first year?
It's a possibility, yes.
Yep.
Awesome.
Hopefully this year.
Yeah, on your left.
Yes.
So there's the scanning phase, processing, and then you're visualizing.
Components. Yeah.
Yep, and the visualization, that's performed on a local computer.
Yep.
Yep, and the scanning's done with existing resources.
Existing. Yep.
Yep, and then the processing of that scan data into whatever format you're putting into the final phase, where is that processing being done?
That also happens on the local machine.
Yeah, and it's instant, almost instant. So, and that's all done. We're done. We're product ready now.
Gotcha. And where was that developed? Was that in-house? Was that in partnership with the
In-house,
university?
all
That's all
proprietary.
in-house.
Yeah.
Gotcha. Because that processing of all that data and simplifying the geometries to be put into the interface, that is all really interesting technology.
Thank you.
Yeah.
Thank you.
And y'all are
Absolutely.
looking potentially license that to other markets as well?
Yes,
Okay.
and are.
Got you. And what are maybe some insights that your team have that enabled that ability? Because I'm just trying to understand why there's numerous labs trying to do that.
Yeah.
There are quite a number of labs. I think the short and simple answer to that is something that I alluded to in the presentation, where Chandra writes these wonderful patents and creates these sci-fi ideas.
I like to
And
say
then-
that I write sci-fi and he makes it real.
Yeah.
Why we were able to do that is, and I'm going to brag for a minute, Scott and I have been friends since we were little, and he alluded to it when he said he started programming at 4, but he is an incredibly brilliant programmer. And where other companies have a bicycle, I have a Ferrari sitting in the garage. So I did it with my horsepower. Did that answer your question?
Yeah, I'd be curious to see it because, you see stuff coming out of Israeli
bet.
defense and you
Yeah.
see things coming out of Stanford, and it's, it'd
Yeah.
be interesting to see something that's better than what they have.
So Stanford and MIT and Harvard all approached us to license from us because they all said they've been trying to in-house develop it for over 30 years
Yeah, no.
and spent a phenomenal amount of money to do
big
that.
issue. Yeah, and
Yeah.
the fact you're doing it with a local computer, that's a whole nother level.
Indeed.
Yeah.
Yeah.
So,
That was the $2 billion. That's how that happens.
deal.
Thank you.
So
Yes.
that question, you can take the data from how many different types of scans, like PET scan, CAT
Any
scan,
DICOM.
MRI,
Any
echo?
DICOM.
Well, all medical scans end up in a format called DICOM. It's essentially JPEG for medicine. So any kind of imaging that they do on any kind of medical scanning device will eventually be translated into a DICOM image set.
Which transfers into industrial as well. So they
Yes.
use the same standard in their industries, be it mining, aerospace. Yeah.
Are you familiar with the NASA and wider than that TRL scale? Technology readiness level scale, and what level of maturity would you classify your technology?
We're product ready. We're done.
So
I can't
TRL
answer you. Could be. I'm not familiar with the TRL scale. We have a slightly different scale back home. So
But we're product ready.
the best I can tell you is that we have a product that we have a technology that's ready to productize.
Yeah.
So I know that everything happens on the local computer, but that's not always the same thing as saying this product is already completely ready to be, deployed in a private network or a single computer completely offline with never touching the real world. Has that already been done?
Yes.
Yeah. We're under NDA though.
We-
So careful.
No, I'll be careful there. But
Yeah.
if we have DICOM on a CD, we could put it onto an air-gapped computer and it will function.
Yeah.
So I'd like to ask a question. So,
Yes.
not that you have to reveal who they are, but do you have current customers that you're working with?
Current customers we're in talks with, yeah, in different industries. So in the medical industry, we're pretty well rooted there. We're in the clinic that's the top 2 in the world. Definitely in North America, but I think they're worldwide. So our medical, we were pretty entrenched. Now we have some aerospace companies that all of you would be familiar with. I can't give out their names, as well as some other organizations. Yeah. I can say some of it offline, but. Any other questions? Okay, thank you.
Aris MD, thank you very much.